let's get started to this series Sabse Tez Maths with Tej. My name is Tejaswini Sudhir, and today we are going to be doing the chapter Matrices. Okay, Matrices is again an important chapter, and potentially you could expect a couple of questions from this particular chapter. Okay, so let's start with understanding what are matrices. So matrices are basically when you have an array of numbers or symbols or expressions which are written in the form of rows and columns. It is known as a matrix. Usually you have a matrix which is inside square brackets. So you have a number, say you have A1, you have A2, it can go on up to AN, and then this can also go on, you can have till BN. Basically, you do not need to remember this notation. What I mean to say is that you can have certain number of rows, let us call the rows as I. You can have certain number of columns, you can call the columns as J. Okay, so matrix is basically when you have a collection of numbers or symbols. You could have just A, B, C, D. You could have anything. For example, you can have a matrix like A, B, C, D, E, F, G, H, I. This could be a matrix. Okay, you can have anything instead of matrix. It's just an array of different symbols or expressions. Array basically means a group of. Okay, for simpler understanding. Okay, now how do you find the order of a matrix? Okay, so suppose you have a matrix which has, this is known as a column. Okay, these are columns and these are rows. This is a row and this is a column. So whenever you're trying to write the order of a matrix, the order will be written as number of rows into number of columns. Do you understand this? So it's always written as number of rows into number of columns. So suppose you have a matrix which is like this: 1, 2, 3, 5, 6, 7, 3, 1, 2. This is your matrix. How many rows are there? 1, 2, 3. So it has 3 rows. So you write 3 into, how many columns does this have? 1, 2, 3. So it has 3 columns. So it is 3 into 3 matrix. That is the order of the matrix. For example, let's take another example. You have 1, 2, 3, 4, 5, 6. This is your matrix. Okay. So the number of rows is 1, 2, 3. So 3 rows and 1, 2. That is 2 columns. Okay. Let's take another example. Suppose you have a matrix like 1, 2, 3, 4, 5, 6. So you have 2 rows, which is 2 into 1, 2, 3. 3 columns. So it is a 2 into 3 matrix. Okay. Okay. So this is what is the order of a matrix. What is a column matrix? A column matrix. What are the columns? The columns are the ones which are like this. So a column matrix is one wherein you have just one column. You can have any number of rows. For example, this is a column matrix. So in this particular matrix, you have 3 rows, but you have only one column. So basically, in a column matrix, whatever is your matrix, you will have I, which signifies the number of rows, into 1. If 1 is the value of J, which is the number of columns, if it is 1, then that is known as a column matrix. Okay. Now some of you may say you don't have all this, it's not written in the syllabus, but it is important for you to know all these terms. That's all I'll say. If you want to skip, you can skip. Okay. So now, what is a row matrix? A row matrix is basically which has just one row but any number of columns. For example, 10, 12, 13. This has just one row but 3 columns. So any matrix which has, where I is equal to 1 into number of rows is J, number of columns is J. That means it can have any number of columns. It can have 1 column, you can have 2 columns, it can have 3 columns, but if it has only 1 row, then that is known as a row matrix. Okay. Next, square matrix. in square matrix, I is equal to j. That is, number of rows is equal to number of columns. Okay, so if I am taking a matrix like 1, 2, 3, 4, you have 2 rows and 2 columns. So this is a square matrix. Or for example, if I am taking 10, 11, 12, 13, 14, 2, 3, 4, 5. This has 3 rows and 3 columns, right? So this is a 3 into 3 matrix, which is again a square matrix. Okay, I hope you have understood this. Let me just erase this and let's go to the next one. So what is a diagonal matrix? In a diagonal matrix, you can have say 2, 0, 0, 0, 6, 0, 0, 0, 4. So any places where A, I, J is written, basically how you denote it is that if you consider an element as A and then the first row is 1, the column is 1, this is A1, 1. For example, if you take this one, it's A3, 1. So in this particular thing, what happens is that if A, I, J is equal to 0, if I is not equal to J, okay. And then the other two. So this matrix, which is a 3 into 3 matrix, can actually be even denoted as diagonal 2, 6, 4. Okay. So this is known as a diagonal matrix. You may or may not be asked this directly, but it's always good to know. Okay. So next is a scalar matrix. A scalar matrix is so if the diagonal elements are equal. So if I have a matrix 13, 0, 0, 0, 13, 0, 0, 0, 13. This is known as a scalar matrix. Okay. Next, what is a unit or identity matrix? This is important. Please remember this one. So unit or an identity matrix is one in which, for example, if you have 1, 0, 0, 1. Or 1, 0, 0, 0, 1, 0, 0, 0, 1. Right? If you have a matrix like this, this is known, this is a 2 into 2 matrix. This is a 3 into 3 matrix. These are known as unit or identity matrix. A unit matrix can be defined as a scalar matrix. In each of the diagonal elements is unity. As you can see, all the diagonal elements are unity. Okay. Next, what is a 0 or a null matrix? So from the name, it is very clear. 0, 0, 0, 0. Or if you want to say in 3, 0, 0, 0, 0, 0, 0. This is a 0 or a null matrix. Okay, let's go ahead. We have just 3 more things which you need to remember. Note it down, please. I hope you're noting all of this down as I'm telling you. A horizontal matrix, which is an M into N or an I into J, horizontal matrix is said to be a horizontal matrix if I is less than J. That means it is a more in a horizontal manner. That is known as a horizontal matrix. For example, my matrix is, this is my matrix, for example, wherein the number of rows is 2 and the number of columns is 3. That means 2 is less than 3, which is basically I is less than J. This is known as a horizontal matrix. Okay. Next, you have a vertical matrix. A vertical matrix is said to be when I is greater than J. For example, you have the number, you have say A, B, D, T, S, W. Okay. Wherein the number of rows is 3 and the number of columns is 2. Wherein 3 is greater than 2, which basically means I is greater than J. And that is known to be a vertical matrix. Okay. Then in a triangular matrix, you have a lower triangular matrix and a upper triangular matrix. A lower triangular matrix is there when, for example, you have lower. See, I have studied all of this when I was in 10th class, and even a lot of people in different places have studied all these things, whether you have a lower triangular matrix or an upper triangular matrix. Aij, so in a lower triangular matrix, Aij is equal to 0 when I is less than j. When is I less than j? I is less than j means wherever, when you are trying to find a particular value, suppose you have it is row number 3 and column number 2. This is I is greater than j. If your I is less than j, I is 1, say column is 3, where 1 is less than 3. So those are known as lower triangular matrix. So for example, you have 1, 0, 0, 0, 2, 3, 4, 5, 6. So what happens here? This one, let's try to find out what is the element. It is A, first row, second column. This one is A, first row, third column. This one is A, second row, third column. What about this? It is A, third row, third column equal. This one is what? A, first row, third row, first column, ulta hai. So this is not applicable. Only these three ones, if they are equal to 0, then it is known as a lower triangular matrix. One thing you should keep in mind is that in a lower triangular matrix, the above three things will be equal to 0, and in an upper triangular matrix, the lower three things will be equal to 0. Let's understand what's an upper triangular matrix. So in an upper triangular matrix, you will have 3, 4, 5. These are all fictional values that I'm just creating. So here, what is this? It is basically A, second row, first column. This one is what? A, third row, first column. A, third row, second column. So in all of these places, I is greater than j. If I is greater than j, then Aij is equal to 0. That is known as upper triangular matrix. So you have a lower triangular matrix and you have an upper triangular matrix. This is what you need to remember. Okay. Next, what are the different operations that you can perform on matrices? So one you have equality, another one you have addition. So as far as equality is concerned, for example, if I have a matrix 1, 2, 3, 4 and I have another matrix 1, 2, 3, 4. These are not equal to each other because this has an order of 2 into 2 and this has an order of 4 into 1. Okay? 1, 2, 3, 4, 5, 6, 7, 8. These are not equal because even though they have the same order, they do not have equal numbers. So these are also not equal to each other. But 6, 7, 8, 9 is equal to 6, 7, 8, 9 because each of this one element here is equal to one element here, 2 into 2, and this is also 2 into 2. Also, some people have made this mistake in previous exams, your seniors I mean. These two matrices are not equal because even though all the elements per se are equal, but the position of 1 here is not equal to the position of 1 here. Therefore, these are not equal. Okay? This is all that you need to know with respect to equality of matrices. Okay? Next, how do you do the addition of matrices? Addition of matrices will follow the simple ways in which you do addition of matrices. Okay? For example, if you have 1, 2, 3, 4 plus 5, 6, 7, 8. So this will be element to element. 1 plus 5 is 6. 6 plus 2 is 8. 3 plus 7 is 10. 8 plus 4 is 12. So this will be addition of matrices. So there are three things that you must keep in mind. One is the commutative property, which means that A plus B, you denote matrices with a capital letter A or B or C. Okay? A plus B will be equal to B plus A. Okay, whatever the order, A plus B will be equal to B plus A. Associative property will be, if you have A plus B plus C will be equal to A plus B plus C. Any order you can do it. This is known as the associative property. You don't need to remember the property per se, but always remember that this can be done. It is there in the rules. Okay. So, for example, if you have A plus B is equal to A plus C. A and A can be cancelled and then you can get B is equal to C. This is possible in matrices. Okay. You can cancel on either side and you can get the final value that is allowed. Next, this is all very easy type of questions. Now let us go to what is multiplication. This is the more important part. This entire page I think is the crux of what are the difficult questions per se which can come in matrices. So for example, for multiplication by a scalar, suppose I have a matrix A which is 2 minus 3, 6, 4. And I am asking you 3A is equal to how much? So if it is 3A, you will do 3 is the scalar which will be multiplying with each of the elements in the matrix. So 3A will be equal to 3 into 2 is 6. 3 into minus 3 is minus 9. 3 into 6, 6 3s are 18. 4 3s are 12. So, if you have a matrix A which is 2 minus 3, 6, 4, 3A will be 3 2s are 6, 3 into minus 3 is 9, 3 6 are 18, 3 4s are 12. This is known as multiplication by a scalar. The scalar here is 3 which we have taken in the example. What if you have multiplication of two matrices? There is a rule that you have to follow. So, if you have Aij which is the order of the matrix into B Mn for example, if this is the order of the matrix, then J is equal to M, only then the multiplication can take place. Okay. Basically what this means is that the number of columns in the first matrix should be equal to number of rows in the second matrix. Please write down that in your notebook whenever you are performing any sort of multiplication. Let us take a more simple example. For example, I have two square matrices 1, 2, 3, 4 into 1, 3, 5, 6. Okay, this is 2 into 2. This is also 2 into 2. Here the column is 2, here the row is 2, so therefore they can be multiplied. What will happen here? You will have 1 into 1 is 1. Let me write it as 1 into 1 plus 2 into 5. 1 into 1 plus 2 into 5. Then 3 into 1 is the next element plus 2 into 6. Okay. Then 1 into 3 is the next element plus 4 into 5. Next element 3 into 3 plus 4 into 6. So what is basically happening is that we go in the first matrix you go by the row, in the second matrix you go by the column. So it is 1 into 1 plus 2 into 5, 1 into 3 plus 2 into 6, 1 into 3 plus 4 into 5, 3 into 3 plus 6 into 4. This is how you do the matrix multiplication. Okay. Now you can easily calculate these values. I will not go into it. Basically, you have to do 1 into 1 plus 2 into 5. Always there will be a plus sign in between. Okay. If there are any minuses in the entire equation, you must accordingly multiply, find the minus and see whether the entire thing will get minus. Okay. In the questions you will understand how exactly this is to be done. Okay. This is how matrix multiplication is done. Next, what do you mean by transposing a matrix? Transposing a matrix basically means if you have an order, if you have the matrix of an order 3 into 2, Then when you transpose it, A to the power of t is known as a transpose. It will have an order of 2 into 3. So what this means is that, for example, let me take 1, 3, 5, 6, 2, 4. That is my matrix, is of the order 3 into 2. I am going to transpose this. So I will get 1, 5, 2, 3, 6, 4. Okay, which is of the order 2 into 3. How did this happen? Basically, whatever is in your row, you should move it to that column. Whatever is in your row, you must move it to the column. You are transposing it. You are changing the order. If it is m into n, it will become n into m. That is what you understand by transposing a matrix. Okay. That's all as far as the theory part is concerned for matrices. Now let us go with the question. This is your first question. Please start solving it. Please pause the video and start solving the question. Okay? Okay. What are they asking you? They have given you a couple of matrices. They are asking you AB plus 2C plus minus 4D. Right? Chalo, shuru karte hain. What is the order of A? 2 rows, 2 columns, 2 into 2. What is the order of B? 2 rows, 1 column, 2 into 1. Order of C? Again 2 into 1. Order of D? Again 2 into 1. AB they are asking you. AB, let us first try to solve it. AB is how much? You have to do matrix multiplication. You know that 2 here, so it can be done. Possible. Right? You may even be asked questions like they'll give you 2 matrices and ask you if matrix multiplication is possible. This could be one question which could come as your MCQ, and then they may say ki do the matrix multiplication. So when you do 3 minus 2 minus 1 4 into 6 1. This is your matrix multiplication that you need to be performing, right? So you have 6 3s are 18. Always remember that if you are having these two as common, your final answer, the order will be what is left, that is this into this. It will be 2 into 1. That means you will have 2 rows in 1 column. So 6 3s are 18 plus minus 2 into 1. Okay. Then minus 1 into 6 is minus 6 plus 4 into 1 is 4. So you have 18 minus 2, which is 16, and minus 6 plus 4, which is minus 2. Right? Did you get the order as 2 into 1? 2 rows, 1 column. So that is one trick which you can know. Okay? Next, we are asked to find 2C. Can I just rub this and write a 16 and minus 2? Yes. 16 minus 2. So this is 16 and minus 2, right? 2C. 2C is nothing but scalar multiplication. 2 into minus 4, 5. 4 2s are 8, so it is minus 8. And 2 5s are 10. You should multiply by each of the elements. So minus 8 comma 10. 4D is equal to 4 into 4 2s are 8. 4 2s are 8. Right? Now, we are trying to find out AB plus 2C minus 4D. Are they all the same dimensions, order? This is 2 into 1. This is also 2 into 1. This is also 2 into 1. Okay. Let's try to add up the first element. 16 minus 8 minus 8. 16 minus 8 is 8. 8 minus 8 is 0. So the first element up is 0. Then minus 2 plus 10. Minus 2 plus 10 is 8. 8 minus 8 is 0. So you get a null matrix. This is the answer to the first question. 0, 0. That is the answer to the first question. Okay. Next, let us go to the second question. Let me just do it. Okay, can you please start by calculating this? You have the matrices given here and that is the operation that's to be performed. Start. Okay, let us now try and solve the question. Okay. So, 2 into A into B plus C into D transpose. So, let us first try to find out this part and then we'll find this part and then we have to just add them together. Okay, 2 into A into B. Let us first do 2 into A. 2A will be how much? 2 2s are 4, 2 into minus 2 is minus 2, 2 into 3 is 6, 2 into 0 is 0. Into B, B is this much. So we will do 2A into B will be nothing but A is how much? 4 minus 2, 6, 0 into B is 1, 2, 0, minus 1. Okay? This is your 2, 4 minus 2, 6, 0 and 1, 2, 0, minus 1. Let us try to multiply them now. First, you know this is 2 into 2, this is 2 into 2. So finally you are also going to get again a 2 into 2 matrix. We know that already. This is going to be 2 into 2. Okay. 4 into 1, 4. Minus 2 into 0, 0. 4 into 2, 8. Minus 2 into minus 1, minus and minus becomes plus, 2 into 1 is 2. 6 into 1, 6. 0 into 0, 0. 6 into 2, 12. 0 into minus 1, 0. So you have 4 plus 0, 4. 8 plus 2, 10. 6 plus 0, 6. 12 plus 0, 12. So 2 into A into B is 4, 10, 6, 12. Correct? So let us just write it down here that 2AB is equal to 4, 10, 6, 12. Okay. Now let us go to the second part of the question. What is the second part of the question say? You have to do C into D transpose. First of all, let us see what is D transpose. D transpose will be nothing but you have D which is 2 into 1. So it will become 1 into 2 which is minus 1 comma minus 1 3 which is 1 into 2. C which is CD transpose will be nothing but will be equal to 4 minus 2 minus 1 3. Correct? So you have, so here it is 2 into 1, here it is 1 into 2. So 1, 1, therefore you will get with 2 into 2 will be your expected matrix. So when you are trying to do this particular multiplication, you will get minus 4, 4 3s are 12, minus 2 into 1 is 2, minus 2 into 3 is minus 6. Am I right? Minus 4, 4 3s are 12, minus 2 into minus 1 is 2 and minus 2 into 3 is minus 6. So minus 4, 12, 2, minus 6. Okay. Now can we add up these two things? 2AB plus CD transpose will be equal to plus here बीच में. So you have 4 minus 4 which is 0. Then you have 10 plus 12 which is 22. 6 plus 2 which is 8. 12 minus 6 which is 6. Right? So the final answer would be 0, 22, 8, 6. This is the answer for this particular question. I hope you have understood this. Okay? Let's go to the next question. Okay, so the next question is determine the 2 into 2 matrix M such that A plus 2M is equal to 3B. Then find M transpose. Okay, so this is they're asking for you for the inverse, the others way. Okay, A plus 2M. So they say A plus 2M is equal to 3B. We have to find 2M. m we have to find out. So 2m is equal to normal equation 3b minus a. Correct? Let us first find this. So 3b will be what? 3 into 2, 6. 3 into 1, 3. 3 into minus 1, minus 3. 3 into 4, 12. So 3b minus a will be 6 minus 1, 5. 3 minus of minus 2, 5. Minus 3 minus 6. 12 minus 0 is 12. Am I right? 6 minus 1 is 5. 3 minus of minus 2 is plus 2, which is 3 plus 2, which is 5. So I get 5 minus 6, 12. Okay. So then this is a is equal to 3b minus a is equal to 5 minus 6, 12, which is equal to 2m. So what will be m? M will be equal to 5 by 2. We just dividing each of these by, if 2 is your scalar, you are dividing each of them by 2, so you get m. 5 by 2, 5 by 2, minus 6 by 2 is minus 3, 12 by 2, which is 6. Okay? 5 by 2, 5 by 2, minus 3 and 6. They are asking you for m transpose. So m transpose will be equal to, you have 5 by 2 and minus 3, you have to move it that side. So you have 5 by 2, minus 3, 5 by 2, 6. So usually what happens in a 2 into 2 transpose is that your alternate elements will exchange sides. So you have 5 by 2, 5 by 2, minus 3, 6. This is your final answer. I hope you have understood this. So what I want you all to do after this particular video is actually practice a lot of questions based on matrices so that you get a hang of it, especially matrix multiplication. And I think with that you will be all ready for any question that comes in matrices for your board exam. Okay? Thank you so much for watching and I'll see you in the next one.